Okay, welcome to the next part of solving quadratic equations. So in the last video we learned how to solve a quadratic equation like this. So all we did was isolate. So x squared equals 25 just by adding 25 to both sides and then taking the square root of both sides, but you have to do the positive and negative. So there were two solutions, plus or minus 5. But this is one type of quadratic equation. But remember, you can also have quadratic equations where there is just an x term as well. So you have a quadratic equation if the highest power of x is a 2, so there's an x squared term. But there could also be an x term. This is still a quadratic equation. And the question is this one is, how do we isolate x? So the issue here is, if we tried isolating the x squared term by subtracting these and putting them on the other side of the equation, well then we have an x over here. And if you try just isolating this x, then there'd be this x squared term. And you can't combine these two terms because they're not like terms, right? You can't add an x squared and an x term, or you can't simplify it. So there's no real way to, well, there is. We'll learn another way that you can isolate this for x, but it's more complicated. You have to do work before you can get to there. So we're going to look at another way to solve this type of question without isolating. So normally when I say solve, I mean isolate, right? That's what we did with linear. But here you're going to do something else, and it's actually suggested up here by factoring. So how would that help us? Well, let's try factoring this. So if you remember how to factor, two brackets. So I'm just going to factor this expression here, the left side. So the first term is x squared, so there'll be an x and an x. And then I need to think of the numbers that multiply. Product is 2, and their sum is 3. Sum is the middle term, the product the second term. Well, those numbers are 2 and 1. So I have this. I've reduced this to this. So x squared times, x plus 2 times x plus 1 equals 0, right? That's what operation is happening here. Well, how does this help me solve x? Just as an aside, there's sort of a principle that we're going to have to use here. Let's say I had two numbers. A times b is equal to 0. Well, what does that tell me about a or b? So if I multiply two numbers and I get a product of 0, what does that tell me about the two numbers? It tells me that a must equal 0 or b must equal 0. The only way to get 0 as a product is if one of the things you're multiplying is 0. And that actually is a pretty important property. It helps us solve a lot of problems in math. But we're going to apply that to up here. This times this is equal to 0. Well, that tells me that this must equal 0, or this one must equal 0. Well, look at this. This is just a linear equation, and I know how to solve linear equations, right? I have to subtract 2 from both sides. So cancel, and I'll get x equals -2, or then over here I'll just subtract 1 from both sides. So cancel, and I would get x equals 0 minus 1 would be -1. So x is equal to -2, or x is equal to -1. And you can check just by substituting -2 into this equation, and you should get 0. And then substitute -1 to this equation, and again you should get 0. So that's how we solve this. We just have to factor, and then that reduces it to two linear terms. And then because those two linear terms are multiplied to give you 0, one of the terms must be 0. So let's just look at some more examples. So again, we want to solve this. So we'll do the same thing. We'll factor. Then we'll say, okay, so what numbers multiply to -8 and sum to 2? And those numbers are +4 and -2. You can check that satisfies that. So that means that this times this is equal to 0. So that means that this must be 0. Or this one must be 0. Which means x equals -4 or x equals 2. Just by solving the linear equations. So there are your two solutions to your quadratic equation.